Good day everyone and welcome back to our YouTube channel. So we'll be taking physics today and it is Introduction to Physics. So what do you know about physics? Physics is that branch of science that deals with the study of matter and the properties of it with concerning energy, of how matter, how they react with it in the environment, how matter and how different matter or how different matter um react, or how they, their properties in the environment. So we have different branches of physics. Here we have the mechanics, we have electricity, we have magnetism, we have thermodynamics, we have optics, and we have nuclear physics. So let's start with mechanics. What is mechanics? Mechanics. Mechanics is a branch of physics. It is a branch of physics that deals with the study of motion and the influence that is causing the motion. We can have a car or we can have any object moving, and then there can be an influence or a force that is tending to make that object to move. So that is what we now do with mechanics. Mechanics is the study of motion and the influence of, or the cause of the motion. Yeah. The next one is electricity. You might be familiar with this already. Electricity is also the branch of physics that deals with the study of movement of currents from one point to another in a conductor. We all know that a conductor is a material that allows the movement of currents through it. So example of a conductor is a metal, yeah. So electricity is the study of flow of current. That is it. And we also have magnetism. Magnetism Magnetism is that branch of physics that deals with how different objects attract to each other, how a ion or a magnetic object, or a object that has magnetic property, how they attract to each other. So that is magnetism. And we have thermodynamics. Thermodynamics or heat. This is the branch of physics that deals with the study of heat and the heat transfer. So we can have different objects of different temperature, or different temperature that can transfer heat from one object to another. So the study of heat or heat transfer is known as thermodynamics. We also have optics. Optics, you might have heard of this before. Optics is the study of light and how it travels. Study of how light travels from one lens, or study of light travel. Yeah. And lastly, we have nuclear physics. Nuclear physics. Nuclear physics is the study of atomic nuclei of a constituent. Yeah, atomic nuclei. We know that in an atomic nuclei, or in an atom, we have the proton, electron, and the nucleus embedded into the atom. So nuclear physics is the study of the atomic nuclei and the constituents of the atomic nuclei. Okay, next up in introduction to physics is quantity, units, and measurement. So what is quantity? Quantity is a property of a body that can be measured. For example, length, weight, size. So quantity is a property of any body or any substance that can be measured. Up next, we have units. So what is units? Before I explain before I define what a unit is, let's take, for example, we have an experiment, or performing an experiment, and then you were told to find the particular length of a substance or a mixture. If you are told to find the length of something, so you need to use units to specify that you are finding length. The length can be 16 now, and 16 can be kilogram, it can be meter, it can be seconds, it can be 16 seconds. So you need to specify that this 16 is for length, and then it will be 16 meter, obviously. So we can now conclude and say that units is a yardstick that we use to define what a quantity is measured. So it is a yardstick used to define which a quantity is measured. Next up, we have measurements. We know what measurement is. Measurement is process of measuring something. Yeah. So units can be kilogram, meter, or second. So up next, we have fundamental units, fundamental quantity, derived units, derived quantity. So let us go to fundamental quantity. Fundamental quantity. what is a fundamental quantity? It is a quantity that does not depend on others to exist, so it exists on its own. It is fundamental. Yeah, example of fundamental quantity: we have the length, we have weight, we have height, we have volume. Yeah, so it is not dependent on other quantities. But then we have derived quantities. According to the name, derived quantities, according to the name, it is dependent, or you need other quantities to form a derived quantity. An example of a derived quantity is acceleration, velocity, speed. You need quantities like distance and time um to derive velocity and acceleration. Okay. Yeah, some examples of fundamental quantity. Firstly, we have length. Our first fundamental quantity is length, and then the unit of length is meter, and we have the abbreviation, it is used as m. So, and for mass, mass is a fundamental quantity. The fundamental unit of mass is kilogram. Sorry. And then the abbreviation is kg. Next fundamental quantity we have is time. It is measured in seconds. That's the fundamental unit, and the abbreviation is S. For current is also a fundamental quantity. Current is also a fundamental quantity measured in ampere, denoted as A. Yeah. And then we have temperature. Temperature measured in Kelvin. Fundamental, the abbreviation is K. Yeah. Also for amount of substance. Amount of substance. The fundamental unit there is mole. The abbreviation is MOL. And then the last one there is luminous intensity. Luminous intensity. The unit is candela, and then abbreviation is CD. Hope you can see that. So we have 7 basic fundamental quantities and their units. So length, mass, time, current, temperature, amount of substance, luminous intensity, and these are their units: meter, kilogram, seconds, ampere, Kelvin, mole, and candela with their abbreviation. Okay, so we've treated fundamental units and fundamental quantity. Up next, we have derived units and derived quantity. So we have basically many derived quantities and derived units. Since according to the name, you can derive them, you can keep on getting them. They are dependent on other fundamental quantities. Yeah. So let's take for example speed. We all know speed or velocity, it is a derived quantity. Yeah. So the unit, you can derive it or get it by applying the fundamental quantities and their units. So speed, the formula for speed is distance over time. Your distance here is your length, your time here is your measured in seconds here. So you can see that length and time, they are fundamental quantities. So speed now is dependent on length or distance and time. Yeah. So to get the derived unit of speed, we have to combine the units of distance and time. Unit of distance here is meter, and for time here is seconds. So it is written as meter per second, or meter minus seconds, s raised to power minus 1. So let's take another example. Let's take acceleration. Acceleration, as we know acceleration to be the rate of change of speed or velocity with time. So it is written as speed or velocity over time. So not to bother yourself, you don't need to start getting the derived units of this, since you already know it as ms raised to power minus 1. So you do this ms raised to power minus 1, and then for the units of time, which is also seconds. So according to your law of indices, when you have division rule, ms raised to power minus 1 then divided by s, it will be equals to ms raised to the power minus 1, then minus 1. When you have a division, this thing here, you subtract the power. So we now have ms raised to the power minus 2 as the unit of acceleration. It's written as ms raised to the power minus 2 or meter per second. And also we have some derived quantities or derived units that have their own specific units. So let's take for example force. Force is the product of mass and acceleration. So m times a. Your mass here is your kilogram. The unit of mass is kilogram. And then for acceleration, which we've treated before, which is meter per second square, it is force is known as kilogram meter per second square. And it is also known as Newton. So this is the other name of force, or the other units of force. Let's take another one. Let's take pressure. Pressure is known as force over area. Yeah. So force here is kilogram meter per second square. The unit of force kilogram meter per second square over area, which is length. Um area is length times length, which is meter square. Yeah. So it is meter square. So according to your division rule, when we have a division sign here, like I told you previously, you would subtract the power. So kilogram meter per second square times meter square will be kilogram per meter second square. And then the second name or the other name for this is known as Pascal. So up next we have dimensions. So what is the definition of dimension? It can be defined as how a physical quantity is made up of other basic quantities. For example, the basic quantities are your mass, length, and time. How we can express physical quantities, either derived quantities or what would I call it, or fundamental quantities, how we can express them in terms of mass, length, and time. So let's take some example. Let us express some quantities in terms of mass, length, and time. So after expressing them, that's when you now have dimension. So the total answer that you get, or the answer you get after expressing them in terms of mass, length, and time, will be your dimension. Let's take velocity. We know velocity to be distance over time, or displacement over time. Distance is measured in length, so which is L over T. It will be capital T. And also note that all dimensions should be in capital letter MLT. All dimensions should be in capital letter. So then you express it in terms of indices. We now have LT raised to the power minus 1. So let's take one or two more quantities and then express them in terms of MLT, and then we'll get our dimension. Let's take acceleration. Acceleration, we know that acceleration is speed over time, speed of velocity over time, and we've gotten velocity to be LT raised to power minus 1, and then your time over T. So now acceleration, the dimension of acceleration will be LT raised to power minus 2 after applying your rule of indices. So let's take another example, force. We know force to be the product of mass and acceleration, m times a. Mass here is capital letter M. Don't forget, always note that all your dimensions, you're expressing them in terms of capital letter M, L, T, capital letter T, L, and M. So mass here is capital letter M, and then we've gotten acceleration to be LT raised to the power minus 2. So just multiply them together. MLT raised to the power minus 2 will be, so the dimension for acceleration is MLT raised to power minus 2. So you can see how we have derived the dimensions of these quantities using your MLT. We are expressing them in basic quantities. That's according to the definition, expressing them in mass, length, and time. So to learn more, you can definitely research and go and work more or find the dimensions of other quantities. We have so many derived quantities. So I can give you some examples. You can find the dimensions of pressure, you can find the dimensions of volume, and you can also find the dimensions of density and other many more that you can find. Thank